Hi everyone, my name is Kate and I'm coming to you from Peru where I'm a high school physics teacher. This week is Data Week, so I wanted to talk to you about one of the most awesome projects I know of. It's called the IceCube Neutrino Observatory, or IceCube for short. One thing that makes the IceCube project special is that it's located at the South Pole in Antarctica. And I was lucky enough to travel there a few years ago and spend about a month living and working at the South Pole on this project. So what does IceCube do? Well, it's this big telescope that was built to look for tiny little particles called neutrinos that are coming from space. Sometimes we talk about neutrinos as ghost particles. Just like ghosts, they're really hard to see. But a bunch of scientists got together and they put their brains together and they built this really big telescope. When I say really big, it takes up a cubic kilometer of ice in the South Pole. That's right, it's buried under the ice. If you were to take all of that ice and melt it down, you would be able to fill 1 million swimming pools. It's huge. We're hoping that this giant telescope can help us learn more about neutrinos, and in particular, where they come from. Things like supermassive black holes, or exploding stars, or energetic bursts of particles. Some really cool things. And in order to learn about them, well, we need to collect a lot of data. So I'd like to introduce you to one of my friends that I met at the South Pole working on IceCube. His name is Dr. James Casey.
Hello, my name is Dr. James Casey. I am a scientist, and I have a PhD in physics from Georgia Tech, or the Georgia Institute of Technology, where I studied particle astrophysics as a member of the IceCube collaboration.
So James, you've been to the South Pole twice, right? What did you do there?
The first time I went down to Antarctica was for just a couple weeks. I went down to the South Pole and did calibration work. During my second trip down to the South Pole, I was there much longer. I was there for 13 months. My primary role during that time was to make sure the detector continued to stay up and collecting data, and to make sure that data made its way north.
So it sounds like data was a big part of your job at the South Pole. Just how much data are we talking about?
IceCube actually collects a very, very large amount of data. It collects over 1 terabyte of data a day, which is more than most home computers can handle. And so it's a large amount. In fact, it's so much that we have to process it down. What we do with that terabyte a day is we take it and we store it and we put it on hard drives that get shipped north, hundreds of hard drives that are shipped north at the end of the year to be looked at by the scientists. But in the meantime, we're trying to do semi-real-time scientists. So we actually have a cluster of computers, a bunch of very powerful servers down the South Pole that we use to process the data. We take that 1 terabyte of data and we drop it down to about the 10th the size, or 100 gigabytes. And this is just the most interesting parts of the data that we want to see as soon as possible. And we take that and we ship it over the satellite.
That sounds like a lot of data. What sort of techniques do physicists use to sort through all of that data?
So we largely rely on computers to sort through the data. There is so much data, there's no other way we could do it. We just happen to be very fortunate to live in an age where we can do that. Computers have made all sorts of types of experiments possible, because without computers, we would not be able to look at anywhere near as much data as IceCube is producing. So again, not every scientist is interested in the same parts of that data, so some will write applications, they'll write programs and code to go through and filter out the parts that they're interested in and process that further, and then they will just use the parts that they're interested in.
So what has come from all of this data? What sort of discoveries has IceCube made?
So IceCube is doing many experiments and studying many different research avenues. But in particular, it's participating in a thing called multi-messenger astrophysics. This is a type of astrophysics that utilizes experiments around the world simultaneously. So not only are we using IceCube to detect neutrinos, but we're also using satellites or ground-based detectors to detect things called gamma rays. And so recently, IceCube actually discovered neutrinos at the same time as another telescope or set of telescopes discovered gamma rays coming from a blazar. So this was, I believe, a fundamental step forward in how we do astronomy and astrophysics, and in that now we're not just using visual light or normal traditional telescopes, but we're using all sorts of different telescopes around the world to work together to study the universe at once.
So it sounds like we're using that data to help us map our universe from lots of different perspectives. It's pretty cool. I'm curious, as a scientist, what does data mean to you?
So to me, data is extremely important as a physicist. It's what guides us. It's how we build our experiments. It's how we know we're going in the right direction. If we build an experiment and we collect data and that data disagrees with our hypothesis, then we know that we're doing something wrong. We've got to fix it somehow. We've got to revise our hypothesis. We've got to understand the experiment better and different things like that. So without the data, we don't really have any experiment. We don't have anything to show us what's going on. So data is extremely important, and it helps us to understand the universe better.
Thank you so much, James. This was great. Now, all you viewers at home, I'm curious what you can do to learn about the world around you using data. So here's something that I want you to try. Take a look around you and just be curious. Ask yourself some questions. For example, how fast does this plant grow? Or how long does it take for my soup to cool down so that I can drink it? Then ask yourself, what sort of data could you collect in order to learn more about your question? Maybe you use a stopwatch to measure time. Maybe you use a thermometer to measure temperature. Maybe you get out a ruler to measure distance. And then the fun part, you do it. Collect your data. Keep a scientific notebook. Write down all your observations, all the numbers, all of the data that you can think of. And then finally, ask yourself, what did you learn? What's something new that you can learn about your question from the data? I hope you have fun playing with ideas for collecting data around your own house. That's all for this week. I'll see you next week on Outside the Classroom.